In this tutorial, I'll show you how to make some small molecules like this ethene molecule that has a double bond between two carbon atoms, and this ethane molecule that has a single bond, and this benzene molecule that has a ring structure, all made only using Open Babel, which is free software, and a Blender add-on for importing chemical data. Open Babel is a free open source tool that can be used for generating 3D data. Click the download button. I'm using a Microsoft Windows system, so I'm going to download the Windows installer. Install Open Babel, and running the Open Babel GUI graphical user interface in Windows, you should see a screen like this. Set the input file format to PDB, Protein Data Bank format, and set the output file format to PDB as well. Why make the input file format and the output file format the same when one of the main uses of Open Babel is to convert chemical file formats? Well, I'm going to tick this box, Input Below, Ignore Input File, which converts this window into a text editor. To make a model of a molecule, I'm going to type in a list of the atoms in the molecule. I'm then going to use Open Babel to generate 3D coordinates of the atoms. I'm then going to import the 3D data into Blender to make the model. Put caps lock on and type in HETATM, HETATM. Press the spacebar 3 times. Press 1, press the spacebar twice, press C, press enter, type end, and click convert. It appears as though nothing happened, but if we drag to open up the message window, we see that there was a problem reading the HETATM record. Click to place the cursor to the right of the C, press the space bar and insert spaces until the cursor is near the right hand side of the window. Click convert and we get an error message, but one molecule is converted. From typing in a small amount of code, we now have enough information to make a 3D model of a methane molecule with 1 carbon atom and 4 hydrogen atoms and the connections between them. There is an error message saying that our HETATM record doesn't match the PDB specification, but more about that later. To save the output file, untick Output Below Only, click the 3 dots, go to the folder where you want to save your PDB files, type in a meaningful name, and click Save, but the file is not created until you click Convert. I want to take a quick look at the PDB File Format specification, which you can find at this web address, which I'll put in the description below. Scrolling down, there are many record types for storing information about molecules. We're only going to use 2: atom records for storing the coordinates of the atoms, and CONECT records for storing the connections between them. I used HETATM, not atom, but if we look at the specification for atom records, the fields, their types, their locations, and we look at the specification for HETATM records, the fields, the types, the locations, they are identical. Atom records tend to be used for atoms in large molecules or polymers. HETATM records tend to be used for the atoms in small molecules. Open Babel checks the HETATM records against this specification. This line causes the warning message when the chemical symbol for carbon is not found in column 78. Open Babel will convert HETATM records with only two fields completed, the serial number and the name of the atom. All the other fields can be blank, but it does like something there, that's why we had to add the spaces at the end. I'm going to look at three molecules that have two carbon atoms bonded with hydrogen atoms. Ethane that has a single bond between the carbon atoms, ethene that has a double bond, and ethyne that has a triple bond between the carbon atoms. Looking at ethene first, there are two carbon atoms connected to four hydrogen atoms, so we need the 3D coordinates of 6 atoms. I've done the CONECT records for the two carbon atoms. The first carbon atom is connected to atom 2, 3 and 4. It's connected to atom 2 twice to represent the double bond, just as the second carbon atom is connected to atom 1 twice to represent the double bond. Going back to Open Babel, put the cursor in front of end and press enter 3 times. Copy the HETATM record and paste it to the next line and change the serial number to 2. Copy part of the CONECT record and paste, and put in the double bond and 4 spaces. Copy and paste, put in the double bond, 4 spaces, 4 spaces, connect to atom 5, 4 spaces, connect to atom 6. Clicking convert, we get the 3D coordinates for the 6 atoms and correct connect statements, but Open Babel hasn't copied over the double bonds. Untick output below, go to the folder where you are saving your PDB files and save as ethene1.pdb. Click save, but don't forget to click convert. If you want the double bond in the Blender 3D model, then you have to insert the extra connections using a text editor. I'm going to use Open Babel as a text editor. Untick input below, go to the folder where you save the ethene file, select it and open. Tick input below, put the cursor in front of the 2, press 2 and 4 spaces. Put the cursor in front of the 1, press 1 and 4 spaces. In the File menu, save input text as and save as ethene2.pdb. Open Blender to import the PDB file we just created. Before importing the molecule, I'm going to delete everything in the scene. Press A twice to select all and X to delete. To use the Import PDB add-on, go to File, User Preferences, click the Add-ons button, click the Import Export category, find Atomic Blender PDB and tick it, click Save User Settings and close. File, Import PDB. Before I import the ethene file, I'm going to change some of the import settings. The first one I'm going to change is the type of sphere from NURBS to mesh. By default, the atoms are so big that you cannot see the sticks or bonds between them, so I'm going to halve the scale, scroll down and halve the radius of the sticks, and tick bonds to show double and triple bonds. Scroll up, and to save having to make the same changes the next time you import, click the Add Preset button and call the preset Mesh Half. go to the folder where you saved the Ethene file, select it and import. Drag with the middle mouse button to rotate the view and zoom in with the mouse wheel, and we appear to have an extra carbon atom in the middle of our model. Drag to make the properties window wider, drag to open up the outliner window, and there are 4 things in the scene: master stick components, a master hydrogen atom and a master carbon atom. Click the Object Properties button, scroll down until you see the duplication panel. The PDB add-on uses a technique called dupliverts to make the atoms and sticks. If I click None, the duplicates disappear. Press A twice to select all. In the object menu, apply Make Duplicates Real. Now that we have made the duplicates real, we can delete the masters. In the outliner window, right-click on Carbon and delete Hierarchy. Right-click on Hydrogen and delete Hierarchy. Right-click on Sticks Carbon, delete Hierarchy. Scroll to the end, right-click on Sticks Hydrogen, delete Hierarchy. Select one of the carbon atoms, press A twice to select all, and click Join. In the Object menu, transform Origin to Geometry. Click the Object Properties button and give the model a meaningful name, Ethene, and set the X, Y, and Z locations to 0. To square up the model, toggle Quad View. In the right view, press R to rotate, and you can either lay the model on its back or put it on its edge. Toggle Quad View. Click the Material button. Make sure carbon is selected. Click the diffuse color and drag to make it darker, and change shading to smooth. I'm going to call that the end of part 1 of the tutorial. I'll look at ethane and ethine in part 2.